Hello, this is ABBA International Academy. We are continuing with our series of differentiation. But before we start, be reminded that we are providing academic support for students who are doing Cambridge and IB. You can now hire our professional tutors in Hong Kong and all over Africa for online and in-person tutoring services, and you can use these WhatsApp numbers to connect with us. Thank you, and let's get started with what I prepared today. So last time we're using the chain rule to find derivatives of different functions, and I want to do one question just to remind you what we did last time. I left you with this question: find the derivative of this function here by using chain rule. By using the chain rule. We said we can use the chain rule to find the derivatives of the composite functions. Derivatives of the composite functions. When you have two functions like gx and gx, and fx, these two functions can be written as the composite functions in this form of g f of x or f g of x. So we can actually use the chain rule to find the composite function. So that by using the chain rule, you are using the chain rule to find the derivative of the inside function and then the derivative of the outside function. That's what we're doing. So this equation, you can say let y equals to 1 over x square root 5 minus 3x squared bracket. Before we get started here, we can actually distribute this x inside the bracket, and this will be 1 over 5x minus 3x cubed, because 3x squared times x is 3x cubed. Now we can go ahead and say that we can set u to be 5. Okay, let me write this again here for you to see. We can now write y as 5x minus 3x cubed power negative 1. I'm using this rule here that 1 over x can be reciprocated and be written as x power negative 1. That's what I just did. And now I'm going to say u equals to 5x minus 3x cubed. And now y will become, this is my first equation, and my second one, since I'm replacing the expression inside, that is going to change y a little bit, and y is going to be u power negative 1. I'm replacing the 5x minus 3x cubed by u. Now we're going to find the derivative of du with respect to x. So du with respect to x, I will get 5 minus 9x squared. On the other hand, dy with respect to du is negative u raised to negative 2. Now we're going to apply the chain rule. The chain rule says that dy over dx can be calculated by taking du over dx times dy over du. Note this, du and du are going to cancel out, so we're going to remain with dy over dx, and that is what we are trying to find. Now you can go ahead and plug in the du over dx, which is 5 minus 9x squared times dy over du, which is negative u raised to negative 2. And now we can actually rewrite this -1 here. We can put it inside here and put it like this. Then u -2. Now we're going to replace u by what we set it equal to in the beginning. So I said u was 5x minus 3. This time is raised to -2, and this should be the answer. This should be the answer. This is dy over dx. So this is how you can use the chain rule to find the derivative of a composite function. Today we are going to be looking at how we can find the gradient of the tangent using differentiation. Finding the gradient using differentiation. This is not something new. This is what we've been doing so far. This is exactly what we've been doing so far. But this time we're just going to find the gradient at a specific point. At a specific point. And just for your own advantage, let me draw this one again. If you have something like this, if this is your curve, let's say this is your curve, and the function here is y equals to x squared. Let's say I want to find the gradient at this point here, and let's call this point x. Let's call it A. Point A. This is point A. I'm trying to find the gradient of this curve here at point A. So right now we know how to find the gradient function of this curve. We know how to find the gradient function of this curve. In fact, the gradient function of this curve should be dy dx has to be 2x. We know the derivative function of this curve is 2x. This is called the gradient function. Gradient function. We can use it now to find the gradient at any given point. In this case, we are trying to find the derivative. I can put it like this. We are trying to find the derivative of f derivative when x is a. So you can just plug in a in the place of x. So a can be any number. Let's say a is 4. If a is 4, that means this gradient is going to be 2 times 4, which is going to give us 8. This is what we are doing today. We are going to be finding the gradient of a tangent line at a specific point. So you just find the derivative, then you plug in the given point. So if I was to draw a line here, this should be my tangent line. So I'm trying to find the gradient of this tangent line at this point A. Hope that makes sense. Now let's take a look at examples. Example 1, find the gradient of the tangent to the curve we have this curve here, which is provided by this function 4x cubed minus 2x squared plus 1 at the point 1, 3. solution. This is how we're going to do it. So the first step, we're going to start by finding the derivative function or the gradient function of this curve. So we can write it y equals to 4 y equals to 4x cubed minus 2x squared plus 1. So the derivative of this function, I hope you remember this, we have 3 different terms, so we have to find derivative of each term. We need to find derivative of each term. Let me write this for your own advantage if you don't remember this. Then minus this derivative of 2x squared plus derivative of this. So we are finding the derivative of each term. We are going to have 12x squared here minus 4x. Derivative of a constant is 0, so derivative of 1 is 0. So now we have the derivative of this curve. We have the gradient function, which is 12x squared minus 4x. Now we can find the gradient at this point. We can find the gradient at this point. The point is 1, 3. The given point is 1, 3. We're only looking at the x point, only the x value. So we can say that x equals to 1 dy over dx should be equals to 12 times 1 squared minus 4 times 1, and the answer should be 8. So this is the gradient of this curve, for x cubed minus 2x squared plus 1 at the point 1. Remember what I said in the beginning, that the gradient of the curve is not constant, it keeps on changing. So if you have another point, let's say at 2, if x is 2, we're expecting to have a different gradient. Okay, let me give you another example. That I hope that this is going to be a little bit tricky. Find the gradient of the tangent to the curve y equals to 4x squared minus 5x plus 2 at each of the point where the curve meets the line y equals to 5x minus 6. Find the gradient of the tangent to the curve y equals to 4x squared minus 5x plus 2 at each of the point where the curve meets the line y equals to 7x minus 6. I want you to pay attention here. We have a line here, and also we have the curve. And according to this question, we are told that this curve is going to meet with this line. It said at each of the point. Now let me draw something here just to try to explain to you what they mean here. Let's say this is our xy plane. We have a curve. Let's say this is a curve. We don't know how it looks like. Just give an example. We have a curve. This is a curve. Let's say this is a curve, and then we have a line. We have another line. This is not the exact curve of this one. I'm just drawing it randomly to show you what's happening. As a matter of fact, this line should have should be starting somewhere below, because it has the y-intercept of -6. So it is intercepting the y-axis in the below the 0. Okay, so this is the curve. Let's say this is my curve y equals to f of x, and then I have my line. Let's say this is the line that this line. Okay, let me use another color. I have a line, and this is the line. This is the line. Let's say this is the line that is given with this equation, 7x minus 6. This is just an example, it's not the exact line. So you can tell here that this line is cutting this curve at 2 points. At 2 points, is crossing this line, this curve at 2 points. This is point A and point B. But what I want you to know is that the value of this line at point A, if I was to say this, the value of this point, the line of this, let's say this, let me call this point is x. Let me call this point here x1. This is x and this is x1. So if I was to plug in here x, this value of x in this curve, this x in this curve, let's call this x0. If I was to plug in this value of x0 into the curve is given by this 4x squared minus 5x plus 2. See, if I'm to plugging in the value of x, which is x0, we don't know this one, we don't know what that is, just a notation that this x here is x or squared minus 5x or plus 2. If I plug it in here and then I plug the same value, I'm going to plug the same value XOR in the line. I'm going to take XOR and plug it in the line. In the line I'm going to have x7 times x, which is XOR, minus 6. So I have two values here. I'm going to have a value here, the first value here, and then I'm going to have the second value here. Since this is the same point, I'm expecting my y value to equal the L value. In other words, I'm expecting the value of this curve at point A to be equal to the value of this line. The value of this function y, I'm expecting it to be equal to the value of this line here. The same will apply to B. So at point B, where x is x1, I'm expecting 4x1 squared minus 5x1 plus 2 to equal the value of the line, of the function of the line, of the straight line. Now the real question is, what is this point A and what is this point B? And that's what you're going to do first. We're going to set the first equation equals to the second equation. We're going to solve to find these 2 points where this line intersect the curve. And that's what you're going to do now. So we're going to say we're going to say, let me write this. Let me rewrite this. And most of the past paper equations, most of the past paper questions are going to be coming in this way. Most of them are going to be coming this way. Please make sure that you're understanding what you're doing, because questions are not going to be straightforward. They're going to need you to think a little bit before you're able to figure out the answers. So it's going to be this way. So this is my second equation. So the first point I'm going to find, the first step is to find out where these two lines meet, the x values where these two lines meet. So I'm going to set the first equation equals to the second equation. I'm going to say 4x squared minus 5x plus 3 equals to 7x minus 6. Then we can rearrange this. Equals to 0. Rearrange it. 12x plus 8 equals to 0. As a matter of fact, we have 4, 12, and 8, so we can actually simplify this by dividing by 4. We can divide this equation by 4. If you divide by 4, we're getting 2, not 2, sorry. We're getting x squared minus 3x plus 2 equals to 0. Now we can actually use a little bit of quadratic equations skills here to split the middle term. So we can split the middle term here, and we're going to have something like x minus 1 times x minus 2 equals to this one. What I'm saying here is this, that I'm expecting my a is 1, my b is negative 3, and c is 2. So I want AC, this product which is 2, I want its product to give me the value of negative 3. So how can I write the product of AC? How can I split these two in such a way that its two factors are going to give me negative 3? The only way to do that is to do negative 2. Negative 1 times negative 2. So negative 1 times negative 2 will give me positive 2, and then negative 1 plus negative 2 will give me negative 3. That's why we have x minus 1 and x minus 2. I hope that makes sense. Now we can actually solve for x. So we're going to say x minus 1 equals to 0, or x minus 2 equals to 0. So you can say x equals to 1 or x equals to 2. So these are the 2 points where this line is cutting the curve. So the line, if this is my curve, this straight line here is cutting this curve at these 2 points. This is 2, this is 1, and this is 2. I hope you understand. This is where you're going to, these are the 2 points that we're going to use to find the gradient. So the question is asking us to find the gradient when x is 1 and when x is 2. Now to find the gradient, we need to find the derivative of the curve. We need to we need to find the gradient function of the curve. We need to find the derivative. I'm going to rewrite it here. This is what we had. dy dx derivative equals to 8x minus 5. This is what you're going to get. So this is the gradient function of this curve. Now we're going to say when x equals to 1, what is dy dx? We're just going to plug in 1 here, and the answer is going to be 3. And when x equals to 2, what is dy over dx? we are going to plug in here again a 2. So 8 times 2 minus 5. 16 minus 1 minus 5 is 11. So the gradient is 3 when x is 1, and the gradient is 11 when x is 2. And that should be our final answer. These are our final answers. So I hope you remember the process. Okay, I'm not going to solve more questions here. Okay, let me solve one question here which involves some algebra. This is our example number 3. Set the gradient of the tangent Okay, it says the gradient of the tangent to the curve y equals to 3x cubed plus ax squared minus x plus 3 at the point x equals to 1 is 3. Find the value of a. So our solution is going to look like this. So I have when x, this is provided, when x equals to 1, dy over dx is 3. When x equals to 1, dy over dx equals to 3. I'm getting this information from here. Okay, I'm getting this information from here. When x equals to 1, dy over dx equals to 3. But unfortunately, we don't have the dy dx first. So we're going to start by finding the dy dx. So the next step is to find dy dx, which is the derivative of this function. So dy dx, let me write the function first. Okay, this is our function. 2x cubed 2x cubed plus ax squared minus x plus 3. Now let's find the derivative of this function. Dy over dx, this is going to be very straightforward. We're going to get 6x squared here plus 2ax. Remember, we're multiplying this a by 2, and then we're reducing this 2 exponent by 1. And derivative of x is 1. And the derivative of 3 is 0. Derivative of a function number. Derivative of a constant number. Derivative of a constant number is 0. So derivative of 3 is 0. Now we have the derivative of this function, and then we have the information that you were provided with, that the dy dx is 3 when x is 1. So we're just going to plug in here. We're going to plug in here. that dy over dx is 1, and x is 3. So 3 squared plus 2a times 3 minus 1. 3 squared is 9, so 9 times 6 is 54, and this one is 6a minus 1. You can see what is going to happen here. You just do 1. You can do 1 plus 1 minus 54 equals to 6a. 1 plus 1, we're moving everything to the other side, and then we're going to solve for this a. So 2 plus 2, 1 plus 1 is 2, and then 2 minus 54. Let's see what we get here. It's negative 52 equals to 6a, so you can divide by 6. So this is the value of your a. The value of a is this one. You can simplify this one more. You can divide this by 2. This is what you're going to get. This should be the right answer if you did not make any mistake anywhere. Yeah, this is correct. Now we're done with that part. The next part that I want to cover real quick is how to find the equation of the tangent and the normal. How to find the equation of the tangent and the normal. How to find the equation of the tangent and the normal. Then I'm going to stop here for today. Okay, let's get started.